All right, here we go. Lesson 2.5, conditional probability. So today's problems should be fairly doable. A lot like lesson 2.1, there's not a whole lot of work to show. Our main idea is that we are calculating a probability that depends, got to spell that right, that depends that another has occurred. All right, here is what the symbol looks like. It's got this funny bar, okay? And the way we read that is not A and B, not A or B, but what is the probability that A happens, key phrase, given that. All right, so this symbol represents the phrase given that B has happened. So one thing depending that another thing has already happened. Let's look at our first example. From a deck of cards, what is the probability that we choose the 2 of clubs given that we're only looking at black? What the important thing to do here is to keep track of your denominator first. And that is the black cards. We're only looking at the black ones. So you remember there is 13 in each suit, so there's 26 total black cards. And there's only one of those. All right? Kids tend to make a mistake on the denominator, not upstairs. So let's try this again. What is the probability that we pick a card that's less than 3, given that we're looking at the cards 1 through 10? Again, this is your world. This is the total. So there's 4 suits and 10 in each suit. So that makes 40 total cards. How many of those cards are less than 3? Well, that'd be a 1 and a 2. And again, because of the 4 suits, that would make 8 total cards. So 8 out of 40. We could reduce that to 1 out of 5. Yeah, a simpler ratio. What is the probability that you select a queen given that you're looking at the face cards? The face cards are Jack, Queen, and King. All right, how many face cards are there then? Well, there's 3 of them times 4 is 12. How many of those are queens? 4 of them. So 1 out of 3 is my probability. Let's look at a different way of doing this problem. This is called a table. Some people refer to this as a two-way table. I don't think that that's necessary to remember that. We have categories, 9th and 10th grade, and then different ways of kids getting to school. We have bus, walking, cars, and other. All right, the important thing to know here is what are our totals in each category. For example, how many total kids ride the bus? 147. 88 walk, and 254 travel in a car. And then there's 11 kids that do some other mode of transport. Looking at it by grade, we have 210 kids who are traveling traveling to school in 9th and 10th grade. In the 11th and 12th grade, we have, I believe the number is 280. I think there's going to be 500 total. Let me add those up quickly. 65, 106, 290. So we have 500 total. All right. What is the probability, first question, that the student walked to school. Notice there's no given that. It's just a simple probability. This is from like lesson 5.1. Well, how many total kids walked? Well, we have 88 kids that walked out of 500. We don't need to reduce that ratio, just leave it there. Okay. You could change this into some sort of decimal, I think this is like 17.6%, but not necessary. What is the probability that the student either rode the bus or is in 11th to 12th grade? Now be careful, this is an or problem. This is tricky. So we're going to look at 11th and 12th graders, all 290, and how many kids rode the bus? 147. All right, see if you can pick up on the error that I'm going to make here. So let's see, 147 plus 290 divided by 500 total kids. So that gives us 437 out of 500. Can you see the mistake that I made? I included all the juniors and seniors and then all the bus kids. I double counted these people. They're in both categories, right? Because they're in this category and they're in this category. So I need to subtract 41 from my total. All right? And that's going to give me 396 out of 500. Now, letters C and D. What is the probability the student was in 10th or 11th? Given that, there's a new phrase, is what we're using today, they arrived in a car. So again, this is your total. How many kids arrived in a car? 254. How many kids of those are 9th and 10th graders? 70. All right, here it is again. This time it's with symbols. There's that, given that. So again, how many 9th and 10th graders do we have? We have 210 kids. How many of those kids rode in a car or drove a car? 70. All right. Good luck in your homework. You got 4 problems to do. They usually involve some sort of table. Pay attention to your denominators in what we call conditional probability.